So the Larock Heteroannulation, also known as the Larock indole synthesis, is a reaction that was proposed in 1991 by Richard C. Larock, who is currently a professor of chemistry at Iowa State University. So this reaction is useful because it's a one-pot synthesis in which we combine ortho-iodoaniline, a disubstituted alkyne, and this is with palladium 0 palladium 2 complex, a ligand, a solvent, metal chloride, and a base. And this gives us a 2,3 disubstituted indole. So this reaction is useful once again because it's a one-pot synthesis, and it's also useful because we can use a variety of disubstituted alkynes to make a variety of 2,3 disubstituted indole products. So when we're looking at the sterics of this reaction, if R2 is bigger than the R3 group on the disubstituted alkyne, the R2 group, the larger group, will go at the 2 position on the indole, which makes this a regioselective reaction.
In the first step of the Larock heteroannulation, there is a dissociation from a palladium with n number of ligands to a palladium with 2 ligands and a chlorine. Then, in the next step, we have an oxidative addition with ortho-iodoaniline to form this negative intermediate here, and we do see that all 4 intermediates in this reaction are negatively charged. With this intermediate, we have a ligand exchange between our disubstituted alkyne and one of the ligands that is attached to the palladium. This forms a bond between the palladium and the triple bond of the disubstituted alkyne. The next step is a carbopalladation, and this forms a bond with one of the carbons from the alkyne and the benzene ring, which is seen in the final product. In this step, we also see how sterics play a role in this reaction, with the smaller R3 group being bonded to the benzene ring, and the larger R2 group being bonded to the palladium. Then we have another ligand exchange, in which we lose the hydrogen that is attached to the nitrogen, which gets us closer to our final product. This forms a bond between the palladium and the nitrogen, forming a 6-membered ring. Then finally there's a reductive elimination to form the 2,3 disubstituted indole product. Here we see that the larger group, the TES group, is in the 2 position on the indole ring. Here we once again see the regioselectivity of this reaction with the larger group at the 2 position next to the nitrogen.